Hi everyone, this is part 2 of the deployment video where I am deploying a full stack JavaScript application and showing this whole pipeline from using GitHub and GitHub Actions to Docker Hub to running it live on DigitalOcean with Nginx. If you didn't see part 1, I'll include a link in the description. Go and check out part 1 first. And I'm just going to wrap up all the steps that I didn't have in part 1 now in part 2, starting with DigitalOcean. I hope you enjoy and feel free to let me know your thoughts in the comments below. If you don't have a DigitalOcean account already, you will want to sign up for one here. It's really simple. You can sign up with one of their options. And you will have to enter your credit card information, but you will not be billed until you actually spin up servers or use some kind of resources on their site. So you basically have to have a credit card on file. Once you have signed up for an account, it's a good idea to create a project so you can organize any servers that you spin up. So I'm going to create a new project here and just call it test project for right now. I have to select a purpose. So that would be web application, click create project. I don't want to move any existing resources into this project. For example, anything I have running in a separate project right now. So I'm just going to click skip. And now I have a project and I can create my server now. So this is called a droplet on DigitalOcean. So I can just click get it started with droplet. You can also create a droplet from this menu up here as well. And I'm going to create Ubuntu. Ubuntu is usually a good idea unless you already know you want something specific, because just about everything runs on Ubuntu since it's the most popular Linux distribution. I don't need anything special. I'm just going to use basic. And then it gives me the default of this $40 a month option, but I really don't need it for testing out a server. I'll just use the $5 a month option. And you can always change this later if you need more. I found with a basic server, this is fine, even with several different Docker containers. If I have something like Redis or Elasticsearch running, then I need one of these more expensive ones. I don't need any extra storage. I'm going to choose something near me for a data center. I don't know which one's better, 1 or 3. I just choose either one. And then I don't need a VPC or anything, but I will need to create a key to SSH into my server. If you're just testing this out, it is fine to use a password, but if anybody is ever going to be using this, then you shouldn't be using a password. You should be using an SSH key. Password seems like it might be easier to set up, but actually an SSH key is pretty easy as well. I'm not going to use any SSH key that I already have on here. I'm going to generate a new SSH key. You can see it gives me some instructions here to generate my public-private key pair, so I need to actually type SSH keygen into the terminal. So I'm going to copy that, come into the root directory of my terminal. I'm going to cd into my .ssh folder, and this is where all of my SSH keys are. This is a pretty standard place to put SSH keys, though you can put it in your project folder if you want to. Just make sure you aren't committing them into your source control. Okay, so now I'm going to paste that command, SSH keygen, hit enter, and it's asking me which file I want to save this in. So the default is ID_RSA, but I'm actually going to call it something else because I have a bunch of keys in here and I'm not going to remember which one's which. So I'm going to call it test project, enter a passphrase. If you want extra security, you can enter a passphrase here. I'm just going to click enter for an empty passphrase. Or no passphrase actually. Enter again. And you're going to see this image generated if your SSH key was generated successfully. So I'm going to clear here. And it's called test project. So I'm actually going to cat test project.pub, and this is the public key. And then I also have a private key. So let me do test project. And this is the private key. Now don't worry, I am deleting this key after I record this video, so it doesn't matter even if you copy these hundreds of characters here. So anyway, the private key you obviously want to keep private on your local machine, and this is what is going to verify that you are the person who generated the public key when you try to SSH into your server. So this is the key that I'm going to copy and put on DigitalOcean, the public key is. By the way, just by highlighting something in the terminal, it automatically copies this instead of doing Command or Control C. So I've copied the public key. Now back in DigitalOcean, I'm going to copy this public key. You can see the check mark in the corner of this box, meaning it's verified to be a correctly formatted key. If you don't get this check mark, then something is wrong about how you copy and pasted your key. So go back and make sure that you actually copied the correct key fully, just like you see on the screen here. I'm going to put the name as the same thing as my key because that helps me find it later. Test project. And I'll click Add SSH key. And you can see this SSH key is selected. You can call your droplet something unique if you want, like Gwen's test project. If you have a lot of droplets, then tags can be really useful. I'm not going to give it any tags. And then something I always enable is backups. So it's only $1 extra per month for the $5 server. Of course, it's 20% of the droplet price. So if you have a $20 server, it's going to be $4 a month. But I think it's totally worth it to get some automatic backups without having to set up anything myself. And then you can always restore from one of the backups. So then you just hit create droplet. It might take a couple minutes to finish setting it up and be ready for you. And that's basically it. That's all you have to do to create a droplet and start using it. I'm actually going to delete this droplet now because I don't need it. So I click destroy down here. Right after it's been created, I'm going to click destroy this droplet. Confirm, would you like to permanently delete? And that's pretty much it. There's one other thing I want to show you, so I'm going to go back into this create a droplet wizard, and that is the marketplace. So the marketplace is similar to the Docker Hub marketplace. You can find droplets that are already set up with certain things on them. So like this Docker droplet. This is actually the one that I used for my server that I'm building in this tutorial. So you can search here for, let's say, Docker, and I can click on Docker. And now it's selected, and you can see now I don't have to choose Ubuntu or anything because this is already Docker and Ubuntu. So basically it will provision a regular Ubuntu droplet, and then certain things will come installed on that droplet from a script. So I'm going to already have Docker and Docker Compose installed and set up according to the recommended settings. So that saves me a couple steps right there. So I recommend looking through the marketplace for droplets that can help you out. I actually run my blog on a ghost droplet that I got from the marketplace, which made it so much easier to set up. It was this ghost droplet. So now the actual droplet that I am running for this project is in this open source project. And you can see it's Docker Ubuntu. So I'm going to be SSHing into this droplet and then show you how I set it up. So what I need to SSH inside of this droplet and install things, I need to copy the IP address. I'm actually going to remove those keys that I'm not going to be using. And now I can SSH with the SSH command. Now if you're on Windows, you can use WSL or some other program to get the SSH command, or use a program called PuTTY, which is often used for SSHing on Windows. But if you're on Linux or Mac, you should be able to use the SSH command just fine. And then you put -I, and then the name of the key, the private key, that is going to be compared to the public key that's already on your server from DigitalOcean. So I'm going to do -I, and then what I called my key. Now I have to denote my user, which by default is usually the root. It's usually called root, although sometimes when you get a droplet from the marketplace, your default user might be called something like admin. You'll have to read the instructions for that particular droplet. If you are setting up just a regular droplet, usually you will SSH in as root, and then you will create new users after you get into the server. So I'm going to do root at the IP address of the server and then hit enter. Now, if this is your first time SSHing into the server, it might ask you if you want to add the key or confirm the key or something, and then you just have to type in yes and hit enter, and then you will be able to SSH in the future. Right away, you can see that a couple things are installed. You can see I have Docker, I also have Git, and then there's another command, docker compose. So I just SSH'd into my server. I'm going to clear this. And just to make everything a bit easier to see here, I am going to replace all of this text in the prompt here with just a $sign. So I'm going to do ps1 equals $sign. I'm going to clear that. And this is my home directory. I can still always do pwd if I don't know where I am. And I created this other folder called DevOps. So now I am inside of that folder, and now inside of this folder, these are the files I have. I also have some hidden files that I'm going to show in a minute. But I basically want to look at this Docker file first. So I'm going to do vim Docker file. And I basically created a very basic Docker file from the node LTS Alpine image. The type of image here really doesn't matter. It's just so I can demonstrate how to create a Docker image and then run the container from that. Actually, here I am going to do echo instead of ls since I'm not creating any new files in this folder. So I'm just going to say echo hello from container. All right, and I'll save that. And now I'm going to basically spin up a container from this Docker file. So there's two different ways that I can create containers. And the first one is with a Docker file that I create, just like I showed in the last video. And the second way is I can use ready-made images. For example, I could pull images from the Docker Hub, Docker repository to my local machine and then run those. So I'm going to look at Docker files first. I'm going to clear this. Now to run that Docker file that I just created, I need to do docker build and period, and that will run a Docker file from the same directory that I am currently in. Now I do want to differentiate the image that I'm about to build from this Docker file by tagging it. So I'm actually going to do -t, or I can do -- tag, and I'm going to call this test, and let's say version 0.1. And how this name works is that to the left of the colon, meaning the word test, will be the name of the container, and then anything to the right of the colon will be a tag. So 0.1 will be the tag associated with the image that I'm building, and of course tags can be associated with multiple different images, but names should really be unique. And now I do need to have the period at the end, so it knows to look in the current directory for a Docker file. And I'm going to click enter now, and that built an image from my Docker file. So now if I run Docker images on here, and I'm going to zoom out because if I'm zoomed in too far, it shows these really weird. So I do have quite a few other images. You don't have to pay attention to those, but this is the image that I just added. So you can see by using the tag command, before the colon was test, and so it gave it the name test. And then after the colon, I used 0.1, and so it tagged it as this. And I could really use any alias. For example, this tag, LTS Alpine, or anything else. Now that I've built my image, I need to create and run a container from that image. So I'm going to do docker run, and then I can give it the ID or the name. I'm just going to give it the name here. Oh, I forgot. So if I just do docker run test, it's going to look for the default tag latest and run that. But since I don't have a tag latest, I gave it a custom tag. So I'm going to have to do docker run test 0.1. And you can see it did in fact run my container, and it echoed out from the command that I ran. Now to see running containers, I need to do docker ps and I can see all of the currently running containers here. Put them on one line. Okay, that's much better. So I can see there's 4 running containers here, and none of them are that test container. Now that is because I am not actually running a server from that container. So basically the container spins up and then exits when it's done, because I have nothing left to run. It was just running an echo command and there was nothing telling it to stay running. So to see containers that have exited, not just the running containers here, I can do docker ps-a. Let me clear this real quick, make it easier to see. And so you can see this first one here is my test container 0.1. It shows when it was created about a minute ago and then exited about a minute ago as well. So it was just created and exited. You can see with some of my other containers, they were created 10 days ago and they are still running, so it'll say up 10 days. So that's basically how you create an image from a Docker file and then spin up a container. If the container has shut down or exited, you can always rerun the container. So you could do docker start to start a stopped container. You can also stop containers or restart containers like that. And I really hope that this video makes you want to start trying out Docker if you haven't tried it out before. It's a lot of fun to use. There's one other way that you can spin up containers, as I mentioned, by using a pre-made image. And I'm just going to pull one from Docker Hub here. So I'm going to do docker pull and then the name of the image I want to pull. And I'm going to pull an image that I'm not already using on the server to differentiate it. So I'll pull the Postgres image and I won't give it any setup or anything here. So you can see it defaults to pulling the latest tag because I didn't tell it to pull any other specific tag. So now when I do Docker images, I can see that, oh, I still have my test image. I have to remove that. But I also have this Postgres image that I just pulled from Docker Hub. Now I want to mention here that Docker Hub is the default repository, but you can really pull from any Docker registry. It doesn't matter. You would just have to tell it where to look for that image if you're not using the default Docker Hub. So to spin up Postgres here, I would just do the same thing because I already have an image. One image was created from a Docker file, the other one was pulled from an external service, but they both work exactly the same way. Now these are just test images, so I want to remove them. So Docker has some convenient commands to remove images and or containers. So I'm going to use the docker rmi command to remove an image and give it the name Postgres. Again, I can use image ID or the name here. And you can see it deleted all the layers of my image. So now if I do docker images, I don't see that image anymore. Now if I do docker rmi test, oh, I have to do the tag, so 0.1, and you can see it won't remove this image because there is a container that has been spun up using this image. So I need to remove the container, and you can do these both together or separately. Now to see that container again, I can do docker ps-a, and I can see that this is the container ID for test, which is already stopped because it exited. So as long as it's not a running container, I can do docker rm to remove a container, and then I'm going to give it the ID of the container. And it gives me back the ID to confirm that it was removed. So now I can do docker psa again, and that container is no longer there. So now if I want to remove the image, I can do, let me look at docker images. I can do docker rmi now and remove test, and I'll remember to tag it this time. And you can see this image only had one layer, so it removed, and now it won't be listed in my images any longer. One more thing about Docker is if you want to pull an image from a private repository, you have to obviously prove your access first. So there is a Docker login command, and then you can do -p and your password, and then -u and your username. And that will try to log you into the default container registry Docker Hub. There are other ways to authenticate, but this one is the easiest. The only issue is that your credentials will be stored on this server. If someone gets into your server, they could have access to your unencrypted credentials, and you can find those credentials in the root directory in the Docker folder and then the config.json file. So if you had logged in here, it would show your credentials, your username and password. It's good to know about this file because you can also update your registry here or your default registry and set lots of other options. So those are the basics of Docker. Now to spin up multiple images, you can see that it would be kind of annoying to have to pull each image manually and then run each image. So Docker has a great way of automating a lot of that, and that is with Docker Compose. So if you look in my directory here, you can see I have a docker compose.yaml file, and that is where I have instructions to spin up multiple Docker containers at the same time. So let me go into that file. I'm just going to add line numbers here for a second. So this is standard, of course, YAML syntax, supposed to be very human readable. You can set the version at the top of the Docker Compose file format so it knows how to parse your file correctly. And then each of these services that you set, like app, API, etc., these will each be containers that I'm spinning up here. And so I'm setting my container name here. Now I don't need a container name, but otherwise it's going to be hard to tell which container is which. And I don't have Docker files locally here, so I am telling it to pull images from Docker Hub. And then I do have my environment variables locally, so I'm telling it, hey, these are the environment variables that I want to be accessible in this container. I'm saying that the front end depends on these other two containers, on the database and on the API here. And then I'm exposing a port. Now this local network basically allows my Docker containers to talk to each other. And there's definitely a few more configuration options that I ideally want to set up with this network, but that's just the basic giving it a name here. Basically the same thing with my API. I'm exposing port 5000, which is what the front end is going to look at for the back end. I'm also setting two files with environment variables, and then I have the database container. Now this is the default port to expose for Mongo, but I've been reading that if I have this on the same local network as my API, I don't actually need to expose this port for the database. I should be able to just use the container name to talk to the container, but I'm still trying to get that to work. So if you know how to do that, then please leave me a comment below. This is the Mongo image that I am pulling from Docker Hub. All of these images are public images, so I don't need my credentials for Docker Hub to log in or pull these images. Here's where I'm setting up that local network. This is the default driver. If you want to know more about drivers for Docker networks, then I'm going to link an article in the description below. I'm not the best person to describe the inner workings of drivers, but I just know that this is the default and usually what you want to use to have containers talking to one another. I know I mentioned this fourth image called Watchtower in the last tutorial, and I really like using this because it actually looks at my other running containers, and anytime they are updated on the registry, it pulls the fresh image from Docker Hub and it spins up a new container, and it shuts down and removes the old container, which is really convenient that it does that automatically. So once I spin up all these containers for the first time, Watchtower really handles all of the updates that I am doing as I merge new code into master, and it spins up those images and pushes them with GitHub Actions to Docker Hub, and then Watchtower watches and checks every 30 seconds for updates to those images on Docker Hub. The great thing about Docker Compose is that with just one command, all 4 of those images will spin up into containers. But as you can see when I do Docker PS, which stands for process status, it's basically to see my running containers. I already have all of these containers running, so I don't want to run my Docker Compose file with everything already running. So I can actually run a Docker command to stop all of the currently running containers And then once they are stopped, I can remove the containers and then I can remove the images. And just to make this a bit shorter, so I don't have to run all three of those commands separately, I'm going to chain them together. I'm going to do stop all containers, remove all containers, and then remove all images, and then I'm going to spin up my images from that Docker Compose file once again. This will take a minute to run because it has to stop everything that's running and delete everything one at a time. Okay, and now if I do docker ps, nothing is running. ps-a, there are no containers, and docker images, there are no images. So I can start fresh now. I am still in my DevOps folder, so I still have my Docker Compose file in here, and then I also have these env files that I created. These are just standard env files that I basically moved onto the server just with a regular scp command. You can copy paste or whatever. Of course, I just never checked these into Git, so no one would see my secret keys. So what I'm going to do here is run docker compose up, and this will look in the current directory for a Docker Compose file and run the file. So it's going to pull all the images and spin up all of the containers that I need with the settings that I have specified. Now, one thing I have to do here is do -d, and that's to run in detached mode. And actually, when I did Docker run that test container earlier, that container shut itself down because it was only echoing one command. But if I was running a server with that container, then it would have actually kept running in my command line instead of running in the background. So to run these containers in the background, I'm going to run in detached mode and click enter. You can see it's downloading the images and all the layers. So all of the containers seem to have been spun up with no issues there. I'm going to just check real quick. So docker ps, and you can see this one spun up 33 seconds ago, and it's been up for 30 seconds, so it's working just fine. And the same with all of them. Docker images, and now I have the 4 images running. Now, one issue here is that Watchtower will pull the latest image every time I make updates to Docker Hub, and while it will remove old containers, it does not remove old images. So that's something that I have to set up separately. And usually I just create a cron job that checks every day or every week or so and just removes any images that don't have containers attached to them. And that works pretty well for me. Again, if you have a better way of doing that, then let me know. But it's pretty easy to write a simple cron job to do that as well. I might show that in a later video. So now my containers are all working, they're all talking to each other. If for some reason they're not working quite right, then I can always use the docker logs command. So I'm actually going to do docker ps, get just any container ID here, and I'm going to do docker logs container ID, and then I can check the logs. There were no logs for the front end, so maybe it would be better if I did the back end here. Yeah, so this shows all of the logs while it's setting up the backend. When it's initially running the node server for production, npm I install the packages for production, hook up to Mongoose, all of the different things. As I make connections to this app, I will of course see all my API logs and my query logs and all that stuff. So that's an easy way to debug if your container's not working quite right. Usually it's something simple like you didn't move the correct files into the correct folder for the container or something like that. It's basically just one simple command to install Nginx on Ubuntu. That is this app command to get the package and install it. There are a few other configuration options to set up, so I'm going to link this article on DigitalOcean for you to check out. So you can get information about the firewall and then set the options that you want for traffic and access to the server. This part only took me about 5 minutes to do. After Nginx is installed, I can take a look at all of the Nginx files and folders by going into etc. Nginx, which was created when I installed Nginx. And you can see if I do pwd, I'm in that folder, and I'm going to open it up with Vim now. So these ones that are highlighted in lighter colors are folders, and I'm not going to go over any of the top 3 folders, because to set up a basic site you just need to know about sites available and sites enabled. Now, sites available is the configuration for any apps or websites that you want to expose to the internet, and sites enabled is actually which ones are currently enabled, and I will talk about how that works in a second. The main file here though is nginx.conf. If you want to know a lot more about what each line does in Nginx here, then I'll be recommending some courses for Nginx and Docker and everything else at the end of this video. Now, most of what's in this file are just configuration options that you can change according to your needs. Some of the important things are line 4 here, where it says include modules. I know we didn't talk about modules, but a lot of times in your setup you're going to start including modules that add certain functionality to your Nginx. So this includes all of those modules enabled. They basically have to be included in this main file for them to work. It does the same thing with sites enabled. So further down in the file, this is line 62, and it also includes anything that we have a pointer to in the sites enabled folder. So it's really important to make sure we have this include. Sites available folder is where almost all of my custom code is. And you can see there's 3 files in here. This default one is just something that came with Nginx when I installed it, and I am not currently using that file. Then I also have HTTP, and then I have my main file, which is called study tracker. Now, study tracker is the only one that is actually working right now. HTTP is actually legacy. I am only using this file currently. And you can see that because this study tracker file is the only one that is in the sites enabled folder. Now you'll notice this is a bit different. It highlights in a different color, and it doesn't look like a normal file because it's not a normal file. So study tracker is actually only a pointer to the file that I have inside of sites available. So it's pointing to this sites available / study tracker. If you've read the book The Linux Command Line, which is a great book by the way, then you should know how to create pointers to other files with the ln command. And basically what this allows me to do is just have pointers here to the files that I am currently using. And if I have files that I might use later or might turn on later, I can keep them in sites available and just get rid of the pointer if I'm not currently using them. So study tracker, if I go into this file, this is actually where my instructions are for Nginx to handle certain types of web traffic. And you can see if I'm getting traffic at /API, at my domain name /API, then I'm telling Nginx to handle it in this way. Some of these settings are optional, but the important one here is this proxy pass that actually passes the traffic on to my container that is running on this server at localhost port 5000, which is that backend Docker container that I'm running. I do the same thing with the front end because that's the web app that I actually want people to see when they go to my domain. So I'm doing proxy pass to the port of my front end that's running. Now at some point this is going to change because after my last video, someone gave me a good tip that I could just have the front end and Nginx Dockerized together. I've always just set up Nginx on my own, but I would love to get a Dockerized setup working as well. Down here, you can see some SSL certificate settings, and these are all, like it says, managed by certbot. So certbot is a way to automatically generate Let's Encrypt SSL certificates for free. And I basically just ran certbot on my server and it added these lines for me. So like it says managed by certbot, I'm not going to change those. That's just taking care of listening on port 443 for SSL traffic. And then if I go down, it also set up a redirect. So for port 80, regular HTTP traffic, it's going to try to redirect to HTTPS automatically for me. So that's also managed by certbot. And like you saw, I had that HTTP file in my sites available folder. But once I installed certbot, I didn't need that file anymore because it set up this code for me. So I'm just leaving this part alone. I'm going to cover more about how certbot works and how I set it up later on in this video. So that's basically it. Once I added this file and created a pointer for this file, then I basically just needed to do service Nginx restart, and that restarts my Nginx and applies the new settings. And so then my app will be available at my IP address. Now for the domain setup, there were a couple things that I had to do. And you can see I have my domain here, which is studytracker.tech. And to set up my domain, the first thing I need to do is point my name servers from where I'm hosting my domain to DigitalOcean. So I need to replace them with DigitalOcean name servers. And you can see DigitalOcean provides tutorials for how to do this on all the different platforms. But it's pretty simple to figure out. You just go to wherever you can manage your name servers, like let's say GoDaddy. Go to wherever the name servers page is and then add these 3 name servers. Whatever name servers are already there, you want to get rid of them so that your domain will only be pointing to these 3 name servers. And then you'll want to add whatever records you need in here in DigitalOcean. And then you will want to create a new domain here. And this is really simple. You just enter the name of your domain and that's it. And then you'll have a page like this for your domain. And you can add whatever DNS records you want. The first thing you are going to want to add is this A record, which directs to whatever the IP address of your server is. So that A record is directing them to this server. So that way when someone goes to studytracker.tech, under the hood it's just going to this server. And then of course I added a couple things for Mailgun to be able to work for my mail server. And that's pretty much it for right now. Of course that will only cover standard HTTP traffic. So how I got SSL or HTTPS traffic working is I used certbot, which is a tool that automatically sets up your HTTPS certificates and then sets up auto renewal for them as well. Now certbot uses Let's Encrypt, which provides free SSL certificates, but they expire after 3 months, so you have to manually renew them or set up some kind of automated process on your own. But certbot sets that up for you, so you really don't have to worry about renewal because as long as your server is running, it is going to check and automatically renew your certificate. The instructions for this are really good. In the past, I've always set up Let's Encrypt with a Python library or install, but this time I decided to try certbot because it is usually recommended as the way to install Let's Encrypt, and it worked out really well. It was actually much simpler. So here I would just say my HTTP website is running on Nginx, because that's what I'm using to handle my web traffic on the server. And then that is on Ubuntu. And then it basically gives you instructions here. Like first you need to, of course, SSH into the server, install some dependencies, and then you can install certbot. One thing to note is that certbot is hitting their API when you run these commands, so you are limited with how many times you can run these commands. So before you run any of the certbot commands, make sure that you have your domain properly set up already and you have Nginx already set up and it's already working for regular HTTP traffic. That's just going to make sure that you aren't rate limited with how many times you can try to generate and set up your certificates with certbot. You get 5 tries within 1 hour or 3 hours, and then if you do more than so many tries, you have to wait a week or so to try it again. So just be careful of that. And that's pretty much it. It also gives you ways that you can test your renewal and also confirm that certbot worked. But you will also get a confirmation in your terminal when you're running these commands for certbot. I failed several times because my domain was improperly configured, because basically I had never confirmed my email address, so my name servers weren't actually pointing to DigitalOcean at first. And it did show me errors in the terminal, and then once I had confirmed my domain and it was actually pointing at DigitalOcean servers and set up correctly, then certbot worked just fine. Once certbot was properly configured, that's when it added these lines into my files, and you can also see it generated the SSL certificates, which are located at ECT Let's Encrypt Live, studytracker.tech, and then fullchain.pem, and then the privkey.pem as well. If you're generating your own certificates, then you'll have to create a folder for them somewhere or put them somewhere, and then you would basically do the same thing. Use the SSL certificate command and then point them to where you've generated your certificate, but this is just much easier to have certbot automatically do all this for you. I want to recommend a couple courses that I've found to be really high quality. Now, the course I originally learned Docker with is no longer available because it was on Linux Academy, and Linux Academy got bought out, I think, last year. But I did find one that's extremely comparable on Cloud Academy, and Linux Academy was bought out by Cloud Academy, so it's probably the same material. So if you want like a really in-depth overview of Docker, I definitely recommend this course. I'm not sponsored or have no affiliation with any of these people or companies. Recently, I was also looking for a good Nginx refresher because I haven't used it since last year, and I couldn't find the course that I originally took again. So I was searching for a really good one, and actually I found an excellent one on Udemy called Nginx Fundamentals. And the teacher Ray V really does an excellent job of breaking down Nginx concepts and what all the different options are. And just overall, I was really impressed by this course. If you want to check it out, I think some of these lectures are available for free, so you can preview some of these. And really, I think $16 is well worth 4 high quality hours of well put together video for this kind of material. Thanks so much for watching this video and this series. I hope you got something out of it. I am always looking to improve my deployment processes, so if you have any suggestions for me, please leave them in the comments below. Don't forget to join my Discord group to chat about coding and get updates whenever I post new content. Also, like, comment, and subscribe right here on YouTube. Hope you have a great day. I'll see you in the next video.